So, big picture video on infrared spectroscopy. All compounds vibrate. Solids, liquids, gases, anything that has a chemical bond vibrates. Now, not all of these vibrations are visible in infrared spectroscopy, and their selection rules we'll talk about when we get into the theory. But generally speaking, most, if not all, organic functional groups have a frequency at which they naturally vibrate. So when we look at infrared spectroscopy, what we're looking for is a frequency that the material absorbs, and that will tell us what the functional group is in that molecule. So infrared spectroscopy is really good at backtracking out what functional groups are present inside an organic compound. And pair this with our 1H, our carbon-13, and our mass spectrometry, and we should be able to backtrack out what we think the molecule looks like. Now, some comments on infrared spectroscopy. First of all, we're going to work with FTIR, Fourier transform infrared spectroscopy. Practically what we do is we expose the sample to an infrared beam and we rock the frequencies back and forth using an IR. And we'll talk more about when we talk about the mechanics of this thing, how this works. But basically we look at a time-dependent spectrum, and the Fourier transform takes us from the time domain to the frequency domain. So when we say FTIR, we're looking at infrared absorption intensity versus frequency, but practically what we do with the measurement is we do it not in terms of frequency but time, and that's where that FTIR comes out. Second, there are a wealth of IR techniques. So even though we're going to talk about FTIR, you're going to see practically in the literature lots of different ways of doing the technique. Now, they have advantages and disadvantages. Typically what we want to work with in organic chemistry, though, is transmission infrared spectroscopy. And the idea with transmission infrared spectroscopy is we have our sample, we shoot the beam through it comes out the other side, we measure the intensity, and we split the beam early on so we can figure out the starting intensity and use that to backtrack out the absorbance. This is not always possible. So sometimes you'll hear things like diffuse reflectance, infrared Fourier transform spectroscopy, drifts, attenuate tail refraction, ATR. There's a lot of techniques out there. Transmission is the most quantifiable, so we will try to stick to transmission when we can. Now, the other thing to keep in mind with IR, if we're working with solid versus gas phase, the solid is going to have lower resolution. And this is kind of a thing that gets lost in the details. If you're working with gas phase, there's a lot of information. Solids behave a little bit differently in terms of how they interact with the infrared beam. So when we work with solids, we're typically not looking at such high resolutions as we would with the gas phase. But again, we'll talk about more of this with the theory. But big picture here. You're going to do the IR and you're going to use this to identify the functional groups. These functional groups should agree with what you see in terms of the carbon-13 and the hydrogen, and they should also agree with what you see in terms of your mass spec.